All right, everyone, here comes round two. For the record, if you ever speak of me, make sure you do it in nice terms. This is the second time I'm shooting this video today. The first time was awesome. It was so good, I nailed it. And then I stopped the recording and it was almost 30 minutes. And even I couldn't bring myself to send it out. So I just deleted it all and I'm starting over because this skill that we're gonna work on today is not a 30-minute skill. It's like a 3-minute skill. And I don't know what I was doing for the other 27 minutes. So let's dive in and get going here. First, a couple reminders. The axis of symmetry. We talked about this last time very briefly. The axis of symmetry is normally represented with a dashed line. For our parabolas, it's always going to be a vertical line. We can identify the axis of symmetry with an equation. X equals -4 is this one. The vertex is always going to be at the peak, the top, or the bottom. In this case, the vertex is at the bottom, so we call it a minimum, and we can identify the vertex as an ordered pair, in this case, -4, -1. There. Let's move on. So those are the basics. Now, what if we need to do a graph of something, right? So last time we talked about doing a graph, and the basic idea is any graph can really be done just with a basic XY table. The trick is picking the numbers over here that make the most sense. We'd like to have 5 numbers if we could, but we need to pick 5 good numbers. So what I'm going to show you is a way in which to pick them, and I'm going to do it kind of quickly. This first example in purple and blue and all these other different colors is already worked out for you. So I'm going to go through it kind of quickly, and you can rewind and go back and watch it again if you need to. First and foremost, there is a new equation that I want you to memorize. It is the equation that will give you the x value in the vertex. It's -b over 2a. The b value is always going to be the one that's by the x. The a value is always the one that leads off the quadratic equation. And while it's not being asked for, the c value is always at the end. C for constant. That's not really what it stands for, but it could. So in colors, I have orange, pink, and red. You can see how I took -8 over 2 times 2. I got -8 over 4, and I got my axis of symmetry to be x is -2. Now, down here in step number 2, I'm going to go ahead and use that axis of symmetry, x is -2. I'm going to put that into my equation in blue. In red, I actually substituted it in, and I got -2, -6. And then here's the idea. This is what I took 25 minutes talking about. Look, if you identify where the vertex is, all you really need to do is find out what's some other stuff around the vertex. Very, very simple. So if the vertex is at -2, let's figure out where it is at -1 and at 0. And then the -3 one is symmetric, so we don't even have to do the calculation. It's almost a free point. And the 0 and the -4 will be free because it's symmetric. So you get 5 for the cost of 3. So it's a really good deal for you. So let's go ahead and look at what happens when you put -1 in. And I've already done that. -1 in produces -4. I already said -2 produces -6. And 0 produces 2, and I have this marked as a free point as step number 3. Get it from your equation as a free point. Here it is, right? That y-intercept is at the end of this thing. Just like in linear equations, y-intercept is at the end. So +2 is a free point. So I have 0, 2, and then you're going to find yourself with symmetry. The -4 goes with -4. And the free point goes with this one. So we get 2 other points for free, essentially. I graph them in red. I draw my dashed line. I create my axis of symmetry equation. X is -2. I identify the vertex. I tell you that it's a minimum, and we're done. That's all there is. It's really just what numbers do we put in the domain. And as soon as you identify that, everything else is pretty easy. So I'm going to do one with you. I'm going to, again, go kind of quick if I can. So let's try this one. I see that my A value is -1, my B value is 4, and my C value is -2. Right off the bat, I'm going to go ahead and do -b over 2a. So -4 over 2 times -1 is 2, so that goes right here. And I'm going to put 2 into this equation. I am going to use one of my calculator tools here. Let's see if I can move that over here. So -x², I love this thing. So I'm going to go ahead and put -x, which we're calling 2 for now, squared, plus 4x, so plus 4x's. And the nice thing is, once I type this in, I'm going to be able to reuse it again, and -2. So I get a 2 out of there, so boom. So my vertex is 2, 2, and like I did before, I just want to identify things that are near the vertex. Near number 2 is number 1, so I'm going to pick a number 1. I could have picked 3, it's the same thing, but 1 is simply easier to work with. Here's what's cool about this equation builder that we have, this calculator. I'm just going to tap on the 2 and replace it with the 1, tap on the 2, replace it with the 1, and now with an equal sign, I learned that my other point is here. I'm going to go with the free point next. 0 and from my equation, -2, so -2. And look how easy I've already calculated 3 of my points. And what I'm going to think about is if this is my vertex, which we identified first, and we went 1, that's symmetric with 3, and 0 is symmetric with 4. So 3 and 4 are going to come out real nice and easy. So let's see, 1 goes with 3, so 1 goes with 3, and 0 goes with 4, so 0 goes with 4, and I have myself a nice clean looking table of values. I don't need the calculator anymore. Here we go, 2, 2, 1, 1, 0, -2, 3, 1, 4, -2, and I have what looks like a great symmetric parabola. Make myself a little sketch, put my axis of symmetry in there. I'm going to go ahead and label it. For style, I'm going to go ahead and label the vertex. I'm going to call it a maximum because it's at the top, and I'm done. Right? We're at 7 minutes into the video, and I'm already done with all of the examples, and well, an example that we worked together as well. All right. One last item, this last piece, this says the function y equals -16t squared plus 72t plus 5 describes the path of a launched t-shirt. Think about throwing something into a crowd. When you throw it, it probably launches from about where your hand is, which is about where your shoulder is, which is about 5 feet off the ground. That's what the plus 5 is meant to represent. If you're really tall, that might be bigger. If you're really short, that might be smaller. The 72 is how fast the t-shirt leaves my hand in feet per second. And the and the -16 is gravity, essentially. It's that t-shirt's being pulled back down to the earth. So let's go ahead and nail this down, right? My procedure is exactly the same. I want to graph this thing so that we can see the path that the t-shirt follows. So just like I did before, I'm going to go ahead and use the calculator option. I'm going to do, well, heck, I have most of it in there, but let's clear it out. So I've got -16 and then t squared. So my t is going to be, well, I guess we need to figure that out, right? So my x value is -b over 2a. There's my negative sign there. So -72 over 2 times -16. So 72, I know this one because I already made the video once today, is 2.25. Here we go, so 2.25, and we're going to square that. And just in case you can't see it, I'm kind of working on this part right here. So next is plus 72t, so plus 72t, and plus 5. So once I have it all in there, that's going to be nice for me. I get 86. So let's see, 2.25 and 86, that's my vertex. I'm going to go ahead and think about things that are near the vertex. Let's see, this is a decimal. So let's go with a 1. I'm going to put a 1 in here. Oops. There we go, put a 1 in, press equals, I get a 61, so that's easy. I'm going to think about how far is my vertex from this point I chose, and it's 1 1/4. So I'm going to go 1 1/4 the other way. So 2 1/4 and 1 1/4 make 3 1/2, and that'll make 61. So you see how I kind of get double value for that calculation I just did, which is pretty cool. And I want one more point because I always want 5 points, but I got to tell you, I see a freebie right here. The freebie point is going to be this plus 5. So if plus 5 is one of my points, think about once again how far away that is from your vertex. That's 2 1/4 away, so I'm going to go 2 1/4 the other way. So 2 1/4 plus 2 1/4 is 4 1/2, and then I can use that 5. So very quickly I got my 5 points, and let's get them graphed. 2.25, and I like to do it this way. So 2.25 and 86 is about here. Let's see. Here's a new dot here. Doesn't always like to do this on the drawing. 1 and 61 is about here. And symmetric to that would be 3.5 and 61. So about right here. And for the sake of argument, here's my line of symmetry, and those dots look about opposite of one another, which is good. 0, 5 is right here. 4.5 and 5 goes here. And I'm going to make my sketch. There we go. So that's approximately what the t-shirt's going to look like when it leaves my hand, when it travels through the air and down the other side and eventually lands on the ground. So let's go ahead and answer a couple questions, and then this video is all done. So we just made the sketch. When is the t-shirt 25 feet off the ground? Well, that's going to be easy. I'm just going to choose a different color here. We're going to go to 25 feet in height, which is right here. And we're going to identify the 2 points where it is 25 feet off the ground. It looks like one of them is at about 1/4 of a second, and one of them is at about 4 1/4 seconds. So 1/4 second, and what did I say? 4 1/4 seconds. All right, question 2. How long will it take for the t-shirt to hit the court? All right, well, let's go look at where it touches the court. It touches the court right here at just a little more than 4.5. So let's say 4.6 seconds. And since we're guessing, I guess we could go ahead and say all of these are approximates. That would give us a little bit of flexibility. What's the maximum height the t-shirt can reach? This actually comes right from the vertex. What's cool is the vertex is the time to max height and max height. So if we pull off the vertex, that's going to answer question 3 and looking ahead, question 4. So my vertex was 2.25, so 2.25 seconds is how long it takes to get there. That's going to go down here. And 86 feet we calculated was the maximum height. So that goes there. So done. I'm going to stretch this video just a teeny tiny bit. On your document, there is one question I'd like you to try. It is pretty straightforward. It's very similar to the last one. There's an equation. How long is it going to take the object to achieve not only maximum height, but how long is it going to take it to get to maximum height? So what is the maximum height and how long does it take to get there? I'm going to ask you to pause the video, try these 2 things. Remember, it's pretty much the vertex. So try those 2 things, come back when you're ready, check the answer, and then we're all done. Hopefully this video helped. It's definitely a whole lot shorter. I'm looking on my screen there. It's 13.5 minutes. Still a little bit lengthy, but it's half the time of the other one, so you're welcome. We'll see you all next week.